I'm about to call you. Alright guys, it doesn't sound like I know some of you guys are reading. I'm looking around to see who got their books open and ready. I got 50% of you guys with their books open, so I'm gonna wait. Everybody find page 474. There's a little graphic about Hurricane Wilma, which you might not remember. 2005 was before a lot of you were born. Yeah, read about it. You should read about it. It's on page 474. I don't remember really. Oh, I didn't live in Florida. Ten out of ten, never. Gonna do my homework. I'm a student.
What is the air pressure at the center?
Alright, you're right. Alright, so this is it. This is a little graphic of Hurricane Wilma. October 2005, that's the latest hurricane. It's the strongest Atlantic tropical cyclone on record. Reaching a pressure of 882 millibars. That's like a physics term about pressure. And its maximum sustained wind speed was 185 miles per hour. So this is a square root formula that's used to measure the well, if you go vice versa, it's the velocity of the sustained wind based on measured pressure, or vice versa. So I don't know who created this square root formula. I don't really even know why, or how. But I think what happens is they collected the data of air pressure and velocity, and it looks something like this. And then when they did regression on software, it looked like a square root function. So they analyzed the relationship between velocity and pressure, and they found this formula to be true. So this is some sort of constant in science, as is this 1013, and so there's a ton of schools in Florida that you can major in meteorology, and there's so many of these word problems in math textbooks. I don't hear very many students saying, yeah, I'm going to go study meteorology. Like, it's a huge field. There's a lot of data in it. You're all sitting here in an honors math classroom. You all have a good number sense and an ability to read data. So I think if you don't have a direction, you should consider it. You should consider studying weather. Yeah, meteorology. They have it right at USF. Yeah. They probably have it even closer schools. Yeah. So anyway, here's your answer. Here's your answer. If the sustained velocity is 54.5, the pressure is 938 millibars. So I guess hurricanes have low pressure. I was reading about it. Low pressure. All right, number 2. Reading on that same page, define extraneous solution. It doesn't tell you the definition straight up. You have to use some reading comprehension to come up with the definition yourself. Go ahead, read that little paragraph under the hurricane problem, and come Yeah, well, it doesn't say the definition very clearly. You have to read it and summarize it yourself. All right, Gage, what did you come up with for extraneous solutions? Gage, you heard that? This is all I related here. Extraneous solutions are solutions that are actually not solutions of the original equation. So it's kind of crazy. The process of solving square root and cube root equations, the way that we do it, the way mathematicians have come out to do it, it's almost flawed. There's like a flawed process because we'll go ahead and solve it and get answers, and sometimes they don't work. So everything was done correctly as far as we understand how to do it, but then when we plug it in, it actually doesn't work. That's extraneous. So when it comes to solving equations with radicals, you have to check because the process is flawed. Yes, Daisy. They will keep asking me this. I think it's like I felt like I just wanted to work in the community. That's great about education is you can really be there for your family and for your community. You can feel like you're contributing that way. I'm not into like sales and marketing. I know there's a lot that goes into like corporations, like accounting and things like that. You gotta feel really good about what you're selling, and I'm kind of not into consumerism and things like that. So it was just a good fit for my personality. I for a little bit looked at accounting. I was in accounting, and wasn't for me. One of my professors was like an Exxon Mobil CFO. You guys know what a CFO is? A chief financial officer, and he said he traveled the whole world, different places where Exxon Mobil was getting oil and things like that, and he was very successful. And he said he never saw his kids, like he never saw his family. Yeah, but he, oh yeah, yeah. And so that was like a deterrent for me in a lot of ways. I really want to be with my family. I just want to have time with my family. Oh, just a little bit. I changed my mind pretty quick. Pretty quick. It definitely was not too hard. Accounting is not difficult. This math right here is more difficult than accounting. So be accounting. No, it's mostly finding ways to save money on taxes. It's mostly tax code. Yeah. All right, you guys, let's look at example 3. I gotta walk you through this. All right. If you were Suzanne, if you were to just read the book, Anton, and learn this on your own, I think most of you would be pretty successful. But I can highlight where I think you might have questions. So first off, you square both sides, right? You're trying to get rid of this radical, has an invisible 2, raise both sides to a power 2. What happened from here to here? What happened from here to here? It has been foiled. Okay, that is a place where a lot of students might mess up on their own. You have to write it out and do a first, outer, inner, last. So keep that in mind. Not every problem requires foiling. Okay, a lot of them are easier. This is actually example 3. So a lot of our questions are going to be easier than this, like example 1 and 2. I'm kind of jumping you into the most difficult one. But I want to highlight places you might make mistakes since we're already on this page. Okay. And then from here to here, I can see what happened. This is a quadratic. To solve quadratics, you need to be set equal to 0. So everything was moved over. Got it. What happened from here to here? Yes? Factoring. You guys, I said it last semester. I said factoring shows up in every single chapter. So what multiplies to negative 14 and adds to negative 5? Negative 7 and 2. So from this point forward, you're solving a quadratic. Sometimes you can factor a quadratic. Sometimes you need the quadratic formula. Sometimes you have to do A times C method. So there's a lot of options once you get down to the quadratic part. Now we have two answers, 7 and negative 2. For some reason it says negative 2 doesn't work. It says negative 2 is extraneous. They use the right process for it. So right now what I want you guys to do is to do a check. Figure out why they said that negative 2 is extraneous. Go ahead, put negative 2 in the original equation and do the math and check and see what makes something extraneous. I also want you to check 7. So plug 7 in, plug negative 2 in, and see why 1 is considered a solution and why is not. Plug that into the problem. Figure it out. Why are you playing frisbees with me? Alright, when I plug negative 1 in, the left side doesn't equal the right side. You get negative 1 equals the square root of positive 1. The square root of 1 is 1. Nope, doesn't equal. And that's why they went ahead and said negative 2, while it appeared to be a solution, was actually extraneous. Now, plugging 7 into the equation, I get 8 equals 49 plus 15. I get 8 equals the square root of 64. I get 8 equals 8, and it does work. So long story short, when it comes to solving any type of equation with a radical, you really need to do a check, like a mental check, and say, wait, is there an issue with this? Sometimes 1 works, sometimes 2 will work, sometimes none will work. And don't always assume it's the negative that doesn't work. Sometimes it's the positive that doesn't work. All right, you guys are going to flip the page, and you're going to do numbers 6 and 8 right now. 6 and 8. And so if I hear you guys getting off task, I'm going to jump into it and move through it pretty quickly, which when I hear you off task, I'm like, and I start going really quick. So I'm going to try to chill, give you a chance to try it yourselves. Really try one. At least do one. You do it mentally. I just do it in my head. So you have to. I received confirmation going to ICC. I hope you're still there for sea lounge. You better be there and running for sea lounge. I think they should bring a second truck in. How many trucks are out there? What do you do first, Julian?
Oh, then you square. That's what I was confused on. Where do I square? So you gotta isolate it.
Yeah, isolate it.
Not bad. Oh, and then the teacher was like, put that away. And he put it like face down.
I don't know.
The teacher was like,
You guys ain't coming around? Nope. Do you? Which one you guys finished?
I'm almost done with the homework first.
You guys are not monitoring yourselves well enough. Someone to come in and intervene. Of course I am.
finished.
I'm both of them.
Oh, wait, we were supposed to do
No,
two.
no, I'm good. I like you. Number one.
Hey, I finished one.
I finished one.
All right, then hit it. Number 8.
Oh, we gotta do.
I don't know why I said it like that. Student rate. Well, now we're squaring up. Oh, you're thinking big picture, what is X, right? So actually, X is impossible. You're right, but you negative first, and then you can actually square the negative 9. So there's going to be what X. What are the different steps? This one, right? Alright, here we go.
Yeah, what are you trying?
Alright, guys, so number 8. Dylan, you ready? In order to get rid of the radical, you square both sides. So I put the little 2 there, and now it's gone because the exponent of 2 and a square root cancel inverse. So now I have this thing squared, and this is gone. You got 27. Here,
So you can go back
there.
to how does he know?
Alex, get to work. Do a math problem. You already got 8. So you guys started with 8 over there? So I just minus the 10 over. I get negative 9. Square both sides. Everybody good with 8 up to this point? Now we got a factor. What multiplies to negative 18 and adds to 3?
6.
Alright, we got 2 possible answers. It's possible negative 6 works. It's possible that 3 works. You must check.
Oh, yeah. Never mind, I got it.
You gotta check. You gotta plug them in and see in the original problem. Does it make sense? We gotta confirm on 3. Does negative 6? Did anybody check negative 6?
It don't work.
It doesn't work. Negative 4 equal to 16? No, negative 4 is not the square root of 16. The square root of 16 is a positive 4. So let's put a line through it. Reject negative 6. Reject it. That guy's extraneous. Okay. I'm gonna check 3 on the screen. Is 3 plus 2 the same as the square root of 3 plus 22? Is 5 the square root? By George, it is. 3 words. Okay. I know that both of them are negative, that don't work, but sometimes negatives do work. So, I had a hurricane video to show you about Hurricane Wilma and barometric pressure in the middle of tornadoes. However, I found that it was a little too basic for you guys, so I'm going to kind of go off track here and show you a different concept in environmental engineering. It's just a 2-minute video about something that is growing here. That's not it. This is the right one.
The 9.5-kilometer horseshoe would literally ring the harbor of Swansea. Once in place, the huge tides on the English coast will be spinning turbines and creating huge amounts of energy. The 9.5-kilometer horseshoe would literally ring the harbor of Swansea. Once in place, the huge tides on the English coast will be spinning turbines and creating huge amounts of energy.
We open the gates in the tide lagoon, we let the water through the turbines, and we generate electricity. It's 5 Olympic swimming pools worth of electricity every second, and that generates enough electricity for 155,000 homes per year.
The core of the project is this massive generator that is equipped with more than 20 6-meter-high turbines that spin when the tide goes in and the tide goes out, 4 times a day. That is energy the designers say residents can count on, unlike wind and solar, which can be weather dependent.
So that's the biggest difference between tidal power and, say, wind and solar power, is that the wind is intermittent and you get the sun during the day. With the tides, you always have certain electricity at certain times of the day, and then that's staggered, it shifts by 40 minutes every day.
The causeway will be created by slowly building it up with giant sandbags. And on top of that, a 9-kilometer causeway for running, biking, and sightseeing that proponents say will last hundreds of years.
Once we build the breakwater wall, it's going to be there for the next 120 years. When we put the turbines in, they're there for the next 120 years. So what's quite interesting about this piece of infrastructure is it's intergenerational. It'll last for the next 5 generations, producing power throughout its lifetime, working with the rhythm of the tides.
The project will cost an estimated $1.6 billion and take 4 years to build. But it will go a long way towards replacing aging nuclear plants and help the United Kingdom meet its clean energy goals. Kevin Enochs, VOA News, Washington.
Yeah, has anyone here heard of tidal energy? Tidal energy. So I Googled tidal energy in Florida, and
Someone's ever been on a boat, okay. That's waves.
let's see what Florida has to say. So this is from 2014. They've been talking about it, but right here, January of this year, I think is the most interesting one from the University of Florida. Tidal energy proposal wins UF IBM technology contest. Florida hacks with IBM. So they're doing a study that would install 10 tidal turbines off the coast of Jacksonville and power 4,000 homes. So the idea is that wind it's there and it's reliable, but the tides come in and out every day, like it's absolute. So just putting in those turbines in the water as the waves come in and the waves come out and storing that energy, that's clean energy. So this is environmental engineering. It's a huge field. All of our Florida schools offer it. Consider it. In your lifetime, you're going to see these being built on our coast, and you guys could be a part of those projects, right? They're not built yet. They're going to be built. Somebody has to build them. So FAU, I saw on here, Florida Atlantic University. I don't know how difficult it is to get into that school, but they have this energy use project in place for the Gulf Stream to produce electricity. So this specific school, if you think environmental engineering is like something you're interested in and you want something that like has a project already going, getting an internship and something like this, it's a cool career path. That one in England said it would take 4 years to build. So we're not even building them yet. And you guys are going to be in college in like 3 years. So this is like a project that you could be a part of. It's very cool. All right, guys, let's check your drafts from yesterday. All right, here's number 19. I've been walking around. I've been very impressed. I've been seeing people with the right X values under the table. So I know that some of you are getting this. If you're not getting it at all, and you're getting decimals, move forward with decimals so you can get some points.
Oh, for a power wash.
And I searched up like how much you usually charge. Put like 60 to 100 bucks an hour. I'll go for 60. Maybe 70.
All right, here is number 21. I didn't finish the math, but these are the x values that will work. And then right here is the picture of what your graph should look like in 21. What you can do,
Something embarrassing. Probably embarrassing. I said I was gonna take it to the grave. I was like, so. And then I was like, and I was telling her, and then she's like, I was just playing. I was like, no. I was like, in the future. And then she's like, I was just playing.
She was actually about to do it.
All right, now I will skip to 11 and 14. Here's the table for 11, and here's what 11 should look like. It's reflected in ray 2.
I'm not on the
She said you saw that end of
Alright, here's the table for 14.
You can't just talk about it. Have a student just write down.
And here's the picture for 14, right? Any questions on the tables or the graphs? Alright, you guys. You are gonna like today's problems more than graphing, so get into it. Alright, this is yeah, you guys are you're gonna like this better than graphing.